morning everyone. I'm Cristine Joy Remoquillo of BSED major in Filipino. And today we are going to discuss other patterns. So before we go to my main topic, I will give some short discussion on what is pattern in nature and their examples. What is pattern? Pattern is someone or something used as a model to make a copy, a design, or an expected action. It is also repeated or regular way in which something happens or done. The pattern can be related to any type of event or object. For example, colors, shapes, numbers, and think about the tiles that you can see on the screen. And the morning, noon, evening, and night. See, it also have patterns. And also, pattern can be sequential, spatial, temporal, and even linguistic. Next, what is the pattern in nature? Patterns in nature are visible regular forms found in natural world. The patterns can sometimes be modeled mathematically and they include symmetries, fractals, spirals, meanders, waves, foams, tessellations, cracks, and stripes. Later, I will show you the pictures that I mentioned. So, in patterns of nature, may explain the mathematics, physics, and chemistry natural pattern. By studying it, we get an appreciation and comprehension of the environment in which we live and how everything is related by examining the patterns in nature. Here are the examples of patterns in nature. First, the pattern you see in the screen is butterfly and we call it symmetry. The next is the fractals or so-called leaves or trees. Next to it is the foam or bubbles. Next, the meanders, the tessellations, the waves, the cracks, stripes, and also the spiral. All of the pictures in the screen or phenomena create a repetition. So this time, we'll be moving on to the other patterns in nature. I chose the rosette patterns. A rosette pattern can be observed when viewing a printed piece of a loupe or magnifying glass, and from a certain perspective almost resembles a multicolored bouquet of roses. There are two common types of rosette patterns, dot-centered or close-centered, and the other one is clear-centered and open-centered rosette. As the name implies, the dot-centered rosette can be identified by the dot visible in the rose patterns. This type of rosette tends to show a less visible pattern at the cost of a slight gamut and shadow. For those who don't know the word gamut, gamut is not a medicine that we buy in drugstore, but gamut is an entire range or series. It means the extent of lies within the powers of something as to cover or control. Remember, the important thing is you should always have rotation symmetry. That is required. And reflection of symmetry is optional only. I will show you some examples of dot or close-centered rosette. This type of rosette is called dot-centered or close-centered rosette because each of the patterns has a dot in its center. And as you can see in the picture, the dot is small and they are close to each other compared to the clear or open rosette that later I will show you the picture. Before that, we have to remember for dot or close-centered show a less visible pattern than clear-centered ones and have individual dots that land on the top of one another. The second type of rosette is called clear-centered or open-center rosette. It is created by shifting one of the process colors, one half row of dots from the other colors. As you can see in the picture or the dot is big and it has space to each other compared to the dot-centered rosette. Remember, clear or open-centered rosettes show more visible pattern than dot-centered ones and look slightly lighter due to more paper showing between dots. Okay, let's discuss different types of rosette patterns. We have cyclic and dihedral. As I said earlier that for those set patterns, reflection symmetry is not required, correct? So for the patterns that has no reflectional symmetry, rotational only, then we call it cyclic patterns. But if they have reflectional symmetry, they are called dihedral patterns. Patterns may be found all around us and organizing our ideas in bringing order to our life. It also assists us in developing our ability to create logical connection and use thinking abilities. Remember that cyclic has no reflectional symmetry, and for the dihedral has reflectional symmetry only, and it is optional.
Good morning, ma'am. Good morning, classmates. Today, our report is all about other patterns in nature. Before we start, let us know this outline in this topic. Introduction, the nature of a wave, patterns and regularities in the word, and other patterns of wave. Introduction. Waves are disturbances that carry as they move. Why? Because this is familiar to us, because it is relaxing, and because of these existing patterns. A wave can be described as a disturbance that travels through a medium from one location to another location because it is a wind and energy. Natural pattern like the intricate waves across the oceans that governs flow of water, sun, and air. Other patterns of waves. Mechanical waves propagate through a medium, air or water, making it oscillate as they pass by. Oscillate means by swing forward or back forward. Wind waves are sea-surface waves, predictive wind waves models when wind blow over large bodies of sand they create domes in extensive dome fields. Progressive wave distribute energy from a point source to a surrounding area. They move energy in the form of vibrating particles or fields. There are two types of progressive wave. Transverse wave that oscillate perpendicular to the direction it advances. Longitudinal wave are waves that have vibration along or parallel to the direction of travel. Longitudinal wave example, sound wave and seismic waves. Sound waves yung mga naririnig natin. Seismic yung the travel wave energy in earthquake. Transverse wave, example, electromagnetic waves. Radio waves, yung sa mga broadcast. Gamma waves, and light waves. Displacement is the distance a particle moves from its central equilibrium position. Amplitude is the maximum displacement from the central equilibrium position. Wavelength, the distance between the two adjacent points on the wavefront which in phase. Period, the time required to complete a full cycle in a seconds. A remember of the basic. Waves can be represented distance or time graph. Note, look carefully in this graph because they're different of x-axis. This graph shows how the displacement of particles varies along a wave. And also periodicity at a particular location. This graph shows the displacement of particles of point varies with time. Determining speed frequency in wavelength through B equal FA, where B equals speed m over s, F equal frequency hd, A equal wavelength m. You need to be able to derive this equation from speed equal distance over time. The time for one complete wave is a time period, t in the distance, the wavelength I then. Speed b equal distance over time equal at. but has frequency equal 1 over time period. B equal A over T becomes B equal AF. Shows this problem with solution. Show that the wavelength of the 8.0 kHz sound wave in seawater is about 0.2 m. Speed of sound is seawater. A equal B over F equal 1,500 over 8,000 is equal to 0.19 m. Another examples. Slinky wave in slinky is stretched from end to end and is held at rest because its natural position. Waves can be seen crashing a wave beach at the snap of a roof or sound traveling through a speaker. The nature of a wave. Waves are everywhere. That's why we're thankful that we have and also uses contribute to our life. The waves pattern is most often seen with a look in the ocean from above. You can also see wave pattern in nature when the wind blows through the grass. So you can see the grass wind blows because of the air, wind energy, and the strength. Pattern singularities in the way. Waves surging towards a beach. Waves spreading a V shape also is the landing in a parallel. Waves radiating from an underwater earthquake. Radiates in energy. We will observe things through pattern thinking, understand the connection between our world, and hopefully appreciate that mathematics is not a subject complexities and difficulties, but a subject full of beauty and innocence. We will appreciate that mathematics is not complexities and difficulties. If we learn something, kung gusto natin matuto, kung may appreciation tayo, magagawa natin yan. Because mathematics and scientists and art is combination of very powerful of beauty and enhance. Nature's great book is written on mathematics Galileo Galilei because they believe that mathematical relationships reflect real aspect of physical world. And also, truly mathematics goes along with our existence in this world. We have been living with it and using it since then. Understanding ourselves and our nature will help us grow more, become better thinkers and believers that there's really beauty in mathematics also. When you have understanding and appreciation of nature and pattern, it contributes to beauty and good thinking and believers in the beauty of mathematics. That's all for today. Thank you po.
Freeze patterns are patterns that repeat in a straight vertical or horizontal line. Freeze patterns are found in architectures, fabrics, and wallpaper. There are 5 basic symmetry operations that can be applied to freeze pattern. T for translation, G for glide reflection, R for rotation, V for vertical, H is for horizontal. Freeze patterns can be classified into 7 types according to their symmetry. First is T, second, TG, third, TGH, fourth, TV, and yung pang 5, TR, 6, TGRV, 7, TGRVH. Translation symmetry is for T, or translation only. This pattern occurs when a shape moves a certain distance equally over and over, creating a pattern. This is the example of translation symmetry. Next is glide reflectional symmetry. Translation and glide, or TG, occurs when a shape mirrors itself over a horizontal line and then translates a certain distance over. the example. Next is horizontal mirror symmetry. Contains translation, glide, and horizontal, or TGH. Appears as though a mirror is placed below a string of identical shapes. Or you can slice through the center of the pattern to get two identical patterns. This is the example. Next is vertical mirror symmetry. Contains translation and vertical. This symmetry appears as though there is a mirror placed between each shape, or you can make vertical slices between each shape. Imagine being able to slice down or vertically in the middle of letter Y. This is the example. Fifth is 180 degrees rotational symmetry. Translation and rotational, or TR. You can turn the pattern 180 degrees and it will look the same as if it were never turned at all. This is the example. Then next is translation and the reflection symmetry. Contains translation, glide reflection, and horizontal, or TGRH. The glide reflection where arises as the composition of translation and horizontal. This is the example. And next, three generators. Contains translation, glide reflection, horizontal, and vertical. This pattern requires three generators with one generating set, consisting of a translation, reflection in the horizontal axis, and a reflection across a vertical axis. This is the example. These are the examples in real-life frieze pattern. Carpet, borders, and the snakes.
Good day everyone, I am Carmela Gomez Seludo from BSED Major in Filipino, Set A. Our topic for today's video is all about the other types of pattern in nature and mathematics. But before we proceed to our main topic, we need to know what is pattern in nature. Pattern in nature are visible regularities of form found in the natural world. Or in other words, these are the things that we can see in your surrounding or environment that has pattern or forms. This pattern recur in different contexts and sometimes be modeled mathematically. Every day we see patterns and it helps us understand, manipulate, and appreciate the world around us. These are the different types of pattern in nature, but in the case are going to discuss Minder pattern in nature. What is Minder pattern in nature? A Minder pattern includes a series of regular sinuous curves, bends, slopes, turns, or a winding in the channel of a river, stream, or other water course. Minder is one of the patterns you see in nature. So this is an example of Minder. So what is Minder? The term Minder is one which refers to a winding curve or bends in a river. Minders are typical landforms remainder are represented by bends in a river and channel, but can also be seen in other forms throughout the natural environment.
Hello classmates, hello ma'am. Today, I will be discussing one of the patterns in nature, which is the cracks. Introduction. Cracks in cooling or drying media can form captivating patterns of connected networks such as artistic crackular patterns sometimes seen in pottery glazes to those found in dry mud or the polygonal networks covering the polar regions of the Earth and Mars. So for the definition of cracks, crack is a line on a surface of something along which has split with breaking into separate parts. Cracks are linear openings that form in materials to relieve stress. So meaning cracks can be fracture first, then eventually it can be further divided into smaller pieces. So patterns created reveal if the materials is elastic or not. So what is elastic and not elastic material? In mathematics, cracks form in materials to relieve stress, with 120-degree joints in elastic materials but at 90 degrees in inelastic materials. When an elastic material stretches or shrinks uniformly, it eventually reaches its breaking strength and then fails suddenly in all directions and create 120-degree joints. So, conversely, when an inelastic material fails, straight cracks form to relieve stress. Further stress in the same direction would then simply open the existing cracks. Therefore, stress at right angles can create new cracks at 90 degrees to the old ones. Meaning to the old ones are the cracks that have been formed in elastic material. So, cracking patterns are widespread in nature. For example, in mud, rocks, and tree bark, and the glazes of old paintings. So, mud cracks. In nature, mud cracks can be found with both rectilinear and hexagonal pattern. Rectilinear patterns with T-junction pattern encodes information about the order of crack formation as later cracks tend to intersect with earlier cracks at right angles. So when we say right angles, it measures at 90 degrees. So hexagonal patterns with Y-junction. Hexagonal crack patterns are typically seen when a crack network opens heals repeatedly in a thin layer or advances by many intermittent steps into a thick layer. So this is the example of a elastic and hexagonal pattern. Drying elastic mud in Sicily with mainly 120 degrees joints. So meaning rectilinear patterns is basically like inelastic material, while hexagonal patterns is basically like elastic material. So this diagram shows that rectilinear T junction and hexagonal pattern Y junction. So next, additional for mud cracks, construction of cracks in thin layers. When an elastic body cools or dries, it tends to shrink and may crack. Tension is released when a crack opens in a brittle layer as the normal stresses in the film must vanish on the new crack surfaces. So this is the diagram also. So the diagram is about a schematic of thin film fracture. A film of height h under stress, sigma sub 0, and with elastic properties E sub 1 and V sub 1 is adhered to a much thicker substrate with potentially different elastic properties E sub 2 and V sub 2. So the formula. The formula above is used for long straight crack in a thin layer, while the formula below is used for a length scale over stress proportional to a film thickness. So other examples of cracks are tree bark cracks, rocks cracks, glaze of painting cracks. So that's all about my topic. Now let's proceed to how can I relate crack patterns in real life. So for me, I can relate the cracks pattern in real life by realizing the mistakes that we do in our daily lives. Those mistakes are like crux patterns which are constantly repeating, but I believe that from those mistakes we will learn something good in the end. And from these mistakes, we can also create another patterns even more beautiful. So next, how can I show my appreciation to God's creations in our nature? For me, I can show my appreciation for God's creation in our nature by studying and understanding them in mathematics and the different patterns in nature, like how everything is connected in this world. As I study them, I can also acquire deeper connection with my spiritual self. I can also appreciate these creations by giving nature its importance and appreciating all the amazing patterns that we have.
Hi, good day everyone. I am Fanuel Levis Torres from BSED Major in Filipino Set A. Our topic for today's video is all about the other types of patterns in nature in mathematics. But before we proceed to our main topic, we need to know what is pattern in nature. Patterns in nature are the visible regularities of forms found in our natural world. Or in other words, these are the things that we can see in our surroundings or environment that has patterns or forms. These patterns recur in different contexts and can sometimes be modeled mathematically. There are different types of patterns in nature, but in this case, we're going to discuss the stripe pattern in nature. What is stripe pattern in nature? The stripe pattern in nature consists of multicolors. Stripe could be seen on some animals as well as in our foods and in the signs that we could see in our surroundings. We could see the presence of stripes on tigers and zebras' colors, where tigers have vertical lines of black and brown, which helps them to blend in their nature, while zebras have black and white stripes. Even in road signs, stripes are present. Some signs have diagonal and horizontal stripe of white, where every sign obtain different meanings through his patterns. Stripes as one of the patterns in the nature have impact to our life, as it is connected to our vicinity. A simple stripe could also help an animal to blend in their nature.